In this training module, we'll describe proper techniques and methodology for installing sensing elements on chain link fence for FD322 applications. Proper system design, site preparation, and installation technique are all essential to ensure satisfactory and reliable system operation. There are a number of steps involved in system design and installation. The first and perhaps most important step is the initial site survey. In this project phase, all of the system details will be documented for the purposes of defining pre-installation site preparation, conducting system design, and estimating material and labor requirements. The time spent in paying attention to detail while performing these critical tasks will result in a system that performs well, is within budget, and is completed on time. The next two steps are interrelated, but they are so important as to be mentioned separately here. An accurate determination of zone sizing results from detailed and accurate field analysis and measurements. In turn, this allows accurate material requirement estimation, primarily sensing cable and conduit, to be made. The goal is to order enough fiber and conduit to finish the job with minimal scrap. Ultimately, the number and type of APUs required will also fall out from this. And all of these estimates, sensing element materials and supplies, APUs, and labor, will be combined to create a system cost estimate. So the site survey's importance cannot be overestimated. Do it right and do it every time. The last two steps, cable deployment and connection to the APU, are mostly matters of proper technique and installation efficiency. We'll go through the details that will enable you to perform these tasks effectively. The site survey should actually be started prior to visiting the site. Acquire as much site-related documentation as possible, such as maps and drawings, from the customer. Google Earth photos and even topographic maps can aid in your initial analysis and preliminary site design. However, this is no substitute for an actual pre-designed site visit. Once you've completed a desktop evaluation of the site and have concluded that the proposed system is feasible, it's time for a site visit. One of your first tasks will be to walk the entire perimeter, preferably along with the local project manager, so that you can assess the site interactively. You'll be evaluating fence quality and noting obstructions for the purpose of defining what work needs to be done at the fence line before installation can start. There are a number of important observations and measurements that need to be made and recorded during the survey. All proposed APU locations need to be noted, and since this will occur at zone boundaries for FD322 applications, this will also define the zone lengths. And make sure to note the fence height for each zone, since fiber and conduit requirements are dependent on this. All perimeters have entry gates of some sort, and each gate location, physical size, and style must be noted so that protection strategies can be designed. Finally, since reinforced fence areas require extra material and labor, it's important to note the locations of each of these areas. Through a miracle of modern manufacturing technology, we can now offer sensing fiber pre-inserted in conduit at a cost-effective price. Due to the labor-intensive process of manually pulling fiber through conduit, it's highly recommended that you choose the pre-inserted fiber for your projects. Your goal is to order enough material to finish your project with little excess, which will probably end up as scrap. This is why it's so important to make careful measurements during your site survey. Fiber and conduit comes on spools up to 800 meters in length. For other lengths, please consult with your sales representative. Also note that we must have your accurate zone measurements before your system order can be processed. This maximizes our manufacturing efficiency and therefore minimizes your project's time to completion. In order to estimate cable and conduit requirements for a particular zone, the first step is to measure the linear zone length, that is, the distance between the APU and the end of the zone. For a simple loopback zone such as shown here, multiply the length measurement by a factor of 2.2 to estimate the material requirements. The extra multiplying factor accounts for service loops, a moderate number of reinforced fence panels, and measurement errors. Throughout the site survey, every fence panel needs to be checked to make sure that the fence is in good repair and is uniformly tight. A good way to measure fence tightness is to use a fish gauge, a device that's normally used to weigh a fish that you've just caught. Simply hook it through the fence and pull. For a typical non-reinforced fence panel, the exact middle of the section is the area that will deflect the most, so hook it there. For a commercial-grade fence, when a pull of 30 pounds is applied, the fence should deflect no more than 2 inches. Loose fence sections can create excessive nuisance alarms during windy conditions and need to be repaired before installation can begin. So note the loose sections as the site survey progresses. Many fences have metal or plastic signs attached. For example, an electrical substation's fence may have danger, high voltage signs attached at regular intervals. If these signs are free to vibrate in the wind, they'll be a source of nuisance alarms as they repeatedly contact the fence. So make notes of loose signs that need to be tightened, removed, or repositioned. Finally, vegetation such as brush and trees and other obstructions in contact with the fence will need to be removed, so make notes of that. When the wind blows, these materials may also repeatedly contact the fence, thereby becoming a nuisance alarm source. This photo illustrates brush and trees in contact with the fence and barbed wire. These will create nuisance alarms during windy conditions. Note that there also appears to be some vines growing on the fence fabric. This will actually dampen the fence from vibrating during intrusion attempts, also creating a problem. So the moral of the story here is to always keep the fence line free from such obstructions. This must not only be corrected before installation, but must also be a regular system maintenance task. Now let's discuss some system installation details. The first step is installation of the weatherproof enclosures at the fence line. Then the power and system wiring can be installed. System wiring refers to the alarm monitoring interface, which will be done through either relay contacts or an Ethernet cable for TCP/IP-enabled systems. The most labor-intensive installation task will be mounting the sensor element on the fence. When this is done, the optical connectors must be installed and carefully cleaned before connecting them to the APUs. Dirty optical connectors can cause high system noise levels, and in extreme cases, the sensor can even be damaged. So use proper cleaning techniques and inspect the connectors with a ferrule microscope to make sure they're clean before plugging them in. The conduit will be attached to the fence fabric using 18-gauge stainless steel wire ties. Sensys supplies the ties as well as a rugged, easy-to-use twist tool for this purpose. We recommend using a high-security method of installing the ties. First, bend the tie into a U shape. Then, loop the tie through the fence at the intersection of the wires in the fabric's diamond pattern. The high-security method involves proper looping of the tie through the fabric. Do not loop the tie vertically through the fence. Rather, loop the tie through in a direction that's parallel to the fabric as shown here. When the tie is tightened, it becomes embedded within the fence fabric's wire intersection and is very difficult to cut off from the outside. Once you become accustomed to the proper technique, it'll become automatic. The wire ties should be placed every 12 inches. Generally speaking, this will be once every 4 fence diamonds, or you can simply use the length of the twist tool as a measuring gauge. Just be consistent about tie placement. Remember, it's not possible to use too many ties, only too few. The fiber is free to move around inside the conduit, so don't worry about that. However, it is possible to tighten the wire ties too much. Excessive tightening can actually cause the ties to fail over time, since the tension in the metal can cause it to pull apart and fall off the fence. It may take months, but it has been observed to happen. So tighten the ties just enough to prevent the conduit from slipping through the tie. The conduit may be observed to be depressed slightly where the wire contacts it, and that's okay unless the depression is severe. The conduit will be installed on the secure side of the fence, being routed over the fence posts. Place a wire tie on both sides of each post and space the ties 1 or 2 diamonds from the post. The conduit must be in close contact with the fence posts to couple fence vibrations to the fiber, so make sure to apply enough tension to the conduit during the installation. We recommend applying 25 to 30 pounds of tension to the conduit as it's being installed. On a typical chain link fence, Install the conduit about 1/4 of the fence height from the top and bottom of the fence, leaving half of the fence height in between the conduit runs. For example, if your fence is 8 feet tall, place the conduit 2 feet from the ground and 2 feet from the fence's top rail, leaving 4 feet in between. It's important to add about 6 to 10 inches of overlap at zone boundaries to ensure that there are no dead areas in your protection scheme. It's recommended that service loops be installed every 45 meters or so at a fence post as shown here. The loop should be 6 to 10 inches in width and 12 to 18 inches tall and should be installed from the bottom up and the top down, also as shown here. This configuration provides about 1 meter of extra fiber in each loop that can be used if there's a break in the sensing element that needs to be repaired. Most fence lines incorporate reinforced fence panels somewhere along the way. Quite often, these will be at corners or perhaps in repaired areas. The reinforcement will take the form of diagonal bars in the fence panel as shown here. Horizontal reinforcement bars are also used sometimes. In either case, these panels will vibrate less readily than normal panels, and to compensate for that, extra fiber in the form of sensitivity loops should be installed. These loops will have the same configuration as service loops, being 6 to 10 inches wide and 12 to 18 inches tall. Where two reinforced panels adjoin each other, as shown here, it's best to put loops on the post as well as in the middle of the panel. For a single isolated panel, as shown here, a loop from the top and one from the bottom will be sufficient. The principle behind sensitivity loops is that a reinforced panel will vibrate less readily than a similar but non-reinforced panel. So consider adding sensitivity loops where there are large deviations in rigidity between adjacent fence panels. One of the characteristics of a fiber sensor is that as more fiber is installed on a fence section, the more sensitive it becomes. This is because the sensitivity is additive. Actually, adding sensitivity loops decreases nuisance alarms. The reasoning behind this is that a given fence zone should be tuned to catch intrusions on the least sensitive section of that zone, this being the worst case. Usually, the least sensitive section of a zone will be the reinforced portion. Therefore, if the zone is tuned for intrusions on a reinforced panel with no sensitivity loops, the non-reinforced panels will turn out to be too sensitive since they vibrate more readily. The sensitivity loops therefore act as equalizers to make the zone more uniformly sensitive along its length. The final note on sensitivity loops is that the additional fiber adds material cost, and more labor is required to install the loops. This is why it's important to note reinforced sections while performing the site survey. If properly noted at that time, these additional costs can be taken into consideration, thereby making your system cost estimate more accurate. Generally speaking, corner posts on most fence lines are the absolute most solid areas of all. This is because they may have been secured with additional concrete as compared with the normal posts, and the corner posts may be larger in diameter as well. They are therefore less susceptible to vibrations than most of the fence line. So don't forget to add sensitivity loops to the corner posts, and if the adjoining panels are reinforced, add loops to the middle and adjoining posts as well. In general, it's a good idea to place zone breaks at the corners. If this is the case, don't forget to add some zone overlaps at the corner posts. Every perimeter must have entry and exit points, usually in the form of gates. These portals present the most labor and material-intensive sections of your installation. There are various types of gates: small single-man gates, vehicle-width single gates, sliding gates, and double swing gates as shown here. A gate installation such as this, where the zone propagates across the gate, presents one of the most complex installation scenarios, so we'll analyze it here. We'll start by following the conduit across the gate, beginning at the upper left panel and working our way to the right. Since all the panels are reinforced, the first feature we encounter is the sensitivity loop coming down from the top. When the conduit nears the hinge post, anchor it to the fence about 2 diamonds from it and run the conduit diagonally across to the gate panel. Now tie the conduit to the fabric near the bottom of the gate panel in the same fashion and construct a loop of conduit on the panel, adding sensitivity loops along the way. When you return to the hinge post, anchor the conduit about 2 diamonds from it and run the conduit diagonally across and back onto the fence panel. Basically, you're creating a flexible hinge at the fence's hinge post. It's important not to attach the X formed by the conduit to the hinge post at any point. It must be free to flex, and it will since it is quite flexible. Continue the installation by attaching the conduit to the bottom of the fence panel. At this point, the conduit must run across the path through the gate, since by design we've chosen to propagate the zone across the gate. So that means we need to bury the sensor's conduit in a piece of solid pipe that's about a foot under the road surface. Now the sensing conduit runs under the road and comes up onto the fence on the other side of the gate. Attach it to the fence so that it runs up along the hinge post and create another flexible hinge and gate panel sensor loop pretty much identical to the one on the left gate panel. When you're done with this, the sensor will propagate along the top of the fence to the end of the zone. At that point, the sensor will run about a quarter of the fence height from the bottom until it reaches the gate once again. Now, run the conduit underground across the road and continue the bottom run on the other side. This is one of the most complex gate installation scenarios, and that's why it's been explained here. The same basic principles apply for single gates, whether they are the small man gates or wider vehicle width gates. Also, your system can be designed such that when a double gate is encountered, the zone boundary can be put in the middle of the gate. This avoids burying the conduit under the road since the zone now doesn't propagate across it. And it's certainly possible to put any gate on its own zone, although that can be an unnecessarily expensive solution. Sliding gates present an especially difficult barrier to a fiber sensor. However, Fiber Sensys now offers a sliding gate sensor that allows the zone to propagate across and protect the sliding gate. Please contact our sales or tech support team for further information on our sliding gate sensor. We've successfully installed it on sliding gates as wide as 40 feet. Our conduit will expand and contract with temperature. This photo shows the cumulative effect of temperature changes on conduit that's been in place for an extended period. Note the wavy appearance of the conduit as it propagates up and down the fence line. This effect can be minimized by properly tensioning the conduit during installation. We recommend applying 25 to 35 pounds of pull on the conduit as it's being installed. Also, the wire ties need to be tightened to the extent that the conduit does not move back and forth through the wire tie. Remember what was mentioned earlier, however, about excessive tightening of the wire ties. Too much tightening can cause wire tie failure over time. Installing the sensing element on the fence is time-consuming and labor-intensive, but it can be done quickly and efficiently with practice. A 2-person team will work most effectively for this activity, and with just a short time to become accustomed to the process and working with each other, such a team will become very efficient. Using the 2-person approach, person number 1 will start at the first post in the zone and put a wire tie on both sides, making sure to pull the conduit taut to keep it in contact with the post. He'll then move to the next post, and while applying tension to the conduit, he'll put wire ties on each side of that post. So person number 1's job then is to go from post to post to secure the conduit at those points. Person number 2 will lag behind and fill in the rest of the wire ties, placing one every foot. Eventually, person number 1 will encounter some sort of obstruction, such as a gate, for example, and that will slow him down. Person number 2 may catch up at times and will be able to assist in getting by the obstructions. Generally speaking, this method will be pretty fast and efficient. A 3rd team member may be added for super high-quality installations. His function would be to add tension to the conduit as person number 2 adds the wire ties at the posts. This will definitely improve the quality of the installation, but adds an additional manpower expense. Note that it's important for the conduit to be in close contact with each fence post. However, make sure that the conduit does not collapse due to the pull tension applied to it while tightening the wire ties at the post. This concludes our discussion of FD322 installation techniques.